So in this, I'm going to be explaining how to write the balance equations, naming all organic products for the following reactions. So all of these reactions are going to be different ways to prepare an alkane. In A, you're starting with an alkyl halide, isobutyl bromide, and you're adding magnesium and ether. So this is going to be hydrolysis with the Grignard reagents. First, I'll draw out my isobutyl bromide. So butyl means I have 4 carbons, and iso is the geometry of it. So iso means there's a carbon on the connected to the middle one. And I won't draw out where all of them are. I'm just going to put H3s. I have 2 hydrogens and then isobutyl bromide. So I have a bromide on my carbon here. Plus magnesium. In ether. So what's going to happen when I combine this alkyl halide with magnesium and ether? The magnesium is going to be bonded. It's going to replace one of these hydrogens here. So your end product is going to be your isobutyl So now I'm only going to have 1H and I want to have magnesium bromide. I'll actually still have 2. Just the magnesium's replacing the bond with bromide, and bromide's now bonded onto magnesium. So that's the product after this. If it's just magnesium and ether, you're just left with this Grignard right here. So now what's going to happen if I have tert-butyl bromide and I do it? The only thing that's different in B from A is just the geometry of the butyl bromide. Tert is when your carbon here doesn't have any hydrogens, so it's just going to be with your bromide on here. And I'll add magnesium and ether. So what's going to happen when this one is introduced to magnesium and ether? The same thing, magnesium is going to go and bond between the carbon and the bromide. So now you're left with a Grignard reagent. So this is just the first step in hydrolysis with the Grignard reagent. You're trying to get an alkane, but this isn't an alkane. This is your Grignard reagent. So how do you go from this to an alkane? That's explained in C and D. You're taking the product of A and you're going to add water. So what's going to happen? One of your hydrogens is going to replace this magnesium bromide, and your hydroxide ion that's left over is going to go with magnesium and bromide and bond with magnesium. So you're left with CH, CH3, CH3. So this is an alkane, so this whole process starting with an alkyl halide, adding magnesium and ether, and then taking that product and adding water, that takes you from an alkyl halide to an alkane. And then plus your magnesium with the hydroxide ion that's left over, and Br. Now for D, I'm taking the product of B, which was the tert-butyl grignard. CH3 MgBr, and I'm adding water. So again, one of the hydrogens is going to replace the bond with magnesium bromide, and your hydroxide ion is going to bond with magnesium and bromide. So you have H3C, CH, CH3, CH3. And if you look, this product is the same as this one. They're just the same thing all over again. You made the same product with two different geometric shapes of a butane. And your hydroxide just goes with MgBr. So that's the hydrolysis of two different butanes using, or of two different butyl bromides with grignard. So now what would happen if you took the product of A and you added D2O, which is just the same thing as H2O? It's just heavy water. That's what, when you see D2O, the D just stands for heavy hydrogen. So this is heavy water. So we'll take the product of A, which was CH3, CH, CH3, CH2, MgBr. And you're adding heavy water. The same thing is going to happen. One of these molecules is going to replace the bond with magnesium bromide, and your DO that's left over is going to bond with the magnesium bromide. So your result here, see, you still have the two regular hydrogens. It's just one of them is now the heavy hydrogen. And this bonds with magnesium bromide. And that's it. So it's the same thing really as DSC. It's just you're using heavy water. Alright, so F and G. So this is a different way to prepare an alkane. This will actually couple two different alkanes. So if you have two small alkanes and you want a bigger one, one way you can do it is you can couple alkyl halides and use an organometallic compound, which is this lithium and copper iodine. So we'll start with the sec-butyl chloride. So the sec chloride means there would be H2 and Cl there. And you're going to add lithium. I believe that it should be 2 because we need to write balanced equations. So in order to do that, you would need to have 2 lithium. And what's going to happen, you're going to have CH3, CH, CH3, CH, and what's going to happen is, let me just make sure I have all of them bonded correctly. Yeah. Your Cl and H is one of the Cl's and H's. They are going to be replaced with the lithium, and as a result, you're going to have lithium chloride. So that's what happens when you add just the Li to it. So now what happens when we take this, the CH3, CH3, CHLi, and we add the copper iodine. What's going to happen is you're going to have two of these actually. It's going to replace the bond copper has with iodine, and you're going to have one alkane connected to the copper on one side, and then you're going to have another bonded to it. So two of these are bonding onto that copper. So how is that going to look? You're going to have CH3, CH, CH3, CH, Cu, Li. So that's the one, and then you're also going to have one up here too. So two of our sec butyls is now connected to this copper lithium, and the lithium that was from this sec butyl is now connected also to the copper as well. It's just separate from the two sec butyls. So now we're going to take the product of F, which is this, and bond that. And you're going to add ethyl bromide. So we have CH2, CH2Br. And so to balance it, you're going to have the 2 there. So what's going to happen is your bromide here is going to bond with the copper. And after that, you're going to have one of these also go here. So one of this is going to connect with the copper, and one of them is actually connecting to the lithium. So then you have these that are missing a bond, and just the ethyl is going to connect onto the CH3. So how is this all going to look? You're going to have your Cu connected with the Br, and that loses its bond with lithium. So lithium is going to grab onto the other bromide. And then your ethyls are just going to connect with the sec butyls. So you'll have 2 CH3, CH, CH, CH3. 2, there should also be 2 CH3. I think I should have had this as CH2 throughout. That's why I was pausing. But see how we connected the sec butyl with the ethyl bromide? We made two smaller alkenes into one longer one by adding lithium and then the copper iodine and then using the ethyl bromide. So this is how you would take two smaller alkenes and turn it into one bigger one.